Hey, if you're studying for the MCAT, this is for you. Aldehydes and ketones are high yield topics in the chemical and physical foundation section. They show up in nomenclature, reactivity, and even in biochemistry pathways. Instead of memorizing random reactions, you need to know what makes the carbonyl group so reactive and how aldehydes differ from ketones. That's the level of understanding the MCAT tests, and that's exactly what we're breaking down today. Aldehydes, terminal carbonyls. An aldehyde has a carbonyl group at the end of a chain. That carbonyl carbon is always bonded to at least one hydrogen. In naming, swap the E ending for al. The simplest example is formaldehyde or methanal. On the MCAT, spotting that terminal carbonyl is key. It explains why aldehydes are usually more reactive than ketones. Ketones, internal carbonyls. A ketone has the carbonyl group in the middle of the chain, bonded to two carbons. In naming, replace the E with on. Acetone or propanone is the classic example. The MCAT likes to contrast ketones with aldehydes. Both undergo nucleophilic addition, but ketones are less reactive because the carbonyl carbon is less exposed. Nomenclature, carbonyl carbon priority. When naming aldehydes and ketones, the carbonyl carbon gets the lowest possible number. That's because the carbonyl is a high priority functional group. This rule matters because on test day, you'll often see tricky answer choices with misnumbered parent chains. Physical properties, polarity without hydrogen bonding. Aldehydes and ketones have higher boiling points than alkanes thanks to the polar carbonyl group, which allows dipole-dipole interactions. But unlike alcohols, they don't hydrogen bond strongly, so their boiling points are lower than alcohols of similar size. Expect MCAT questions that compare physical properties across functional groups. Reactivity, nucleophilic targets. The carbonyl carbon is partially positive, making it an easy electrophile. Nucleophiles attack here, which is why carbonyl chemistry is dominated by nucleophilic addition. Aldehydes are especially reactive because there's less steric hindrance. Oxidation, aldehydes versus ketones. Aldehydes can be oxidized into carboxylic acids. Common reagents include PCC and stronger oxidizers like KMNO4. Ketones, in contrast, resist oxidation under mild conditions. This difference is one of the most testable distinctions between the two groups. Reduction, going back to alcohols. Both aldehydes and ketones can be reduced. Aldehydes go back to primary alcohols, ketones go back to secondary alcohols. Reagents like lithium, aluminum hydride, or sodium borohydride are fair game on the MCAT. Remember, reduction is just adding hydrogen or removing oxygen. Ketoenol tautomerism. Aldehydes and ketones can shift into an enol form through tautomerism. This equilibrium shows up in biochemistry and in reactions like enolate formation. The MCAT likes to test your recognition that keto and enol forms are interconvertible, not separate compounds. Aldol condensation, building bigger molecules. Under basic conditions, an enolate ion from one carbonyl attacks another carbonyl. That's the aldol condensation. A crossed aldol uses two different carbonyl compounds. The MCAT uses this to test your ability to trace electron movement in carbonyl reactions. Biological significance, metabolic intermediates. Carbonyl chemistry isn't just organic reactions. Ketones show up in ketone bodies during fasting states. Aldehydes appear in sugars, like glucose, which is technically an aldehyde. The MCAT tests your ability to connect organic chemistry with metabolism. Aldehydes and ketones are everywhere, in lab reactions, in metabolic pathways, and on the MCAT. If you understand their structures, reactivity, and how they tie into bigger biological themes, you'll avoid memorization traps and pick up easy points. With that said, here are just a few of our student success stories. Students who mastered these concepts, boosted their scores, and got into medical school. If you're studying for the MCAT, click the link below to get started with your own prep. We help students reach a 515 plus on the MCAT, and we'd love to do the same for you. And don't forget, subscribe to our channel for more MCAT breakdowns like this, and follow us on Instagram for extra tips and resources.